So in this video, I'm going to explain about the third instruction of the group of data transfer or data copying instruction. So this third instruction is called here as a LXI. So the functionality of this instruction is load register pair with immediate values. So here in their format of this LXI, their opcode will be LXI and their operand will be a register pair with 16 bit of data. 16 bit of data. So here this L means load, this X means register pair, and I means immediate data. So that immediate data will be 16 bit of data. And here this RP is denoting here as a register pair. So this is called here register pair, and the register pair used here, so that register pair used here will be BC register pair, which is denoted by B, DE register pair, which is denoted by D, and HL register pair, which is denoted by H, and SP, that is called stack pointer here. So these are the four register pair used as a operand RP here, and this 16 bit of data will be loading into this register pair. For example, let's say we can understand this with the example as a LXI B, 2050H. So what it will do this, after execution of this instruction, this BC register pair will have it here the values as like this is the higher byte as a B and this is your lower byte as a C. So this BC register pair is denoted by this, or this register pair is denoted by higher byte notation only. So that is B. So here this will be loading, this will be loaded here higher byte of the data with this as a 20, and this lower byte as a 50H will be loading into this C register as a 50. So this will be the content of BC after execution of this instruction as a LXI B, 2050H. So we need to keep in mind that as a register pair, what we are using, BC register pair, DE register pair, HL register pair, and SP register pair. SP is called a stack pointer. Let's say we can write this here as a LXI SP, 7FEDH. So this is a 16 bit of data, and this is the stack pointer register. So this instruction is basically used in the stack memory related operation while initializing this stack pointer values. So here after execution of this instruction, this will be having this SP content will have this SP. SP is 16 bit of register. So this is here SP, and this is their higher byte, this is their lower byte. So this lower byte will copy into lower byte place as a ED, and higher byte will place at the higher byte of this stack pointer as a 7F. So this will be the content of a stack pointer after execution of this LXI SP, 7FEDH. Now we need to find out their size. So it's very simple to find out their size, as like earlier I had explained that this LXI B is giving here as an English alphabet followed by 16 bit of data or address is recognized as a 3 byte of instruction. So here the first byte will be taken here as a LXIB. So equivalent to this LXIB, there will be 8 bit of hex code given in the textbook. So from there we will get the code. So let's say their starting address, I am assuming for this instruction, is as a 1000H. So at 1000H, let's say their opcode for this LXIB is having that 8 bit of hex code as a XXH. So as we know that one hex digit is equivalent to 4 binary bit, and 2 hex digit is equivalent to 8 binary bit. So here at 1000H we are storing their opcode. This XXH is called their opcode, and here at the next address will be what 1001H just immediate after this. So this is the lower address, so it will copy this lower byte, or it will store this lower byte of this 16 bit of data. So this will store here as a 50H, and the next immediate address is 1002H. So at this address it will storing, this is the higher address, so it will store higher byte as a 20H. So before execution of this instruction, this code and this operand as a 50H and 20H must be stored into the microprocessor memory, like their external memory, where we store this opcode and operand, and from there while executing these bytes will come from memory to the processor. So let's say here, let's say this is the memory part here, and at 1000H, we are having XXH as a opcode, and at the next address as a 1001H we have this lower byte as a 50H, and at 1002H it is having 20H. So this is the memory part here, and this is connected with this microprocessor. So whenever we will press the execute button, this will be transferring here into this microprocessor by the use of their address line. So now first of all we'll see that their size. So we had seen that 8085 is 8-bit processor, so it will store only 8-bit of data at one location. So this is occupying 3 addresses here. So it is occupying 3 addresses. It means it is storing 3 byte of data for this particular instruction. So their size will be 3 byte. So their size will be 3 bytes. Now we'll talk about that machine cycle. So for execution of this instruction, how many times microprocessor is accessing this memory part, so that many number of times is giving the machine cycle for this instruction. So first of all it will take opcode from the memory. So that operation is called here as a opcode fetch operation. Opcode fetch operation. Once this opcode fetch will be done, then during the decoding and execution of this opcode fetch operation, processor is knowing that next 2 byte must be the data, and while doing that, this decoding and execution, microprocessor is going to select this BC register pair. So this data whatever will come, it will goes to this BC register pair only. It will not goes to DE or HL or SP. It must have to go to this BC register pair, because by the execution of the opcode for this LXI B, it has already selected BC register pair. So they know that microprocessor is knowing that lower address lower byte and higher address higher byte. So after this opcode fetching, this processor will take 50H into this microprocessor from the memory to this processor. So this 50 will be storing into the lower byte of this register pair at the place of C, or we can say that in C register it will store this 50. So then this will access the third location as a 20H, and this will be moving from this memory to this processor through the use of the address line, so that B register will store this 20H. So by this way it is completing the complete execution of this instruction. So these are called the instruction cycle. It means opcode fetch and then memory read as a 50H is the another machine cycle, memory read, and again one more time we need to read this as a higher byte as a 20H. So this is another memory read. So it means how many times this microprocessor is accessing this memory chip for the complete execution of this instruction is giving here the number of machine cycle. So opcode fetch, memory read, It means microprocessor is accessing this memory chip 3 times, so the total number of machine cycle must be equal to 3, and those operations are called as opcode fetch, memory read, memory read. So there is one time opcode fetch, and for all the instruction opcode fetch will happens only once, and then after that this opcode fetch is following this consecutive to memory read. So total number of machine cycle for this instruction is 3, and as we know that for the opcode fetch operation the number of t state required is 4 only, as I had explained earlier that in general it is required 4 only for most of the instruction, so it is 4, and for this memory read it will take 3, so 4 plus 3, and for further memory read it will take 3 more, so total number of t state is 10 here. So by this way we learn about this LXI instruction, that opcode fetch. So their opcode is LXI, their operand is register pair as a B, C, D, E, H, L, S, P, and their second operand is 16 bit of data which is going to be loaded into this register pair, and their size in byte it is only 3 that I had explained here, and their machine cycle is also 3, that is called opcode fetch, memory read, memory read. So there are 3 machine cycle. Machine cycle means how many times it is accessing this memory chip for the complete execution of this instruction. So here if someone will ask about that, what do you mean by instruction cycle? So this instruction is having instruction cycle. This instruction cycle consists of 3 machine cycle, because as I had explained earlier, for the instruction cycle there must be minimum of 1 machine cycle. So here it is having 3 machine cycle, and for the complete execution of this instruction it is required 10 t state, it means 10 clock period. So if someone will ask about that instruction cycle, then we can say that this instruction cycle is having 10 t state, or we can say that 10 clock period it is required to complete their instruction cycle. And if someone will ask how many machine cycle are there in this instruction cycle, then we can say that these are 3. So those are readed as opcode fetch, memory read, memory read. So I hope you got the clarity about their opcode, operand, size, machine cycle, t state, and more important is their operation. Once we know the operation about the instruction, it is very easier to find out their size and their machine cycle and their number of t state.